Welcome to our Math 10 review. This is yours truly, John Alphys Panilia LPT. And now the coverage of this review are as follow. We will talk about permutation, combination, probability of events, union of events, and intersection of events. Let's begin. Mr. Neil wishes to make a bracelet with 10 different beads. How many arrangements of beads can he make? Now we're here with 10 different. So every beads are unique. Now in permutation, keyword is different, unique. In combination, order doesn't matter. While in permutation, order matters. So since different beads, we'll use the permutation. This is a linear. So linear permutation is 10 factorial or n factorial. So in order to get the arrangement of beads, get 10 factorial, or that is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 using your calculator. The answer is 3,628,800 arrangement of beads if we have 10 different beads. That is possible. Mr. Nell is going to arrange his textbooks on a shelf: algebra, calculus, trigonometry, statistics, and geometry. How many different possible arrangements can he make? Again, we're talking about different objects. This is linear permutation also, since we're going to arrange textbooks on a shelf in a row. This is linear permutation. That is n factorial. How many objects do we have? We have 5 objects: the algebra, calculus, trigonometry, statistics, and geometry. 5 factorial is 5 times 4 times 3 times 2 times 1, or simply 120. There are 120 different possible arrangements that he can make. In how many ways can 2 glasses be arranged in a glass rack if there are 12 different glasses to choose from? Again, we have the word different. If the keyword is different or unique, then we'll use the permutation. So this is permutation of n objects taken r at a time. So that is, our n is 12 and r is 2. To get the permutation of 12 taken 2 at a time, we have 12 factorial all over 12 minus 2 factorial. 12 minus 2 factorial is 10 factorial. Then evaluate using calculator. There are 132 different ways that we can arrange the glass rack. There are 6 teams in the final round of a tournament: U, V, W, X, Y, and Z. Question: in how many ways there are 6 teams be arranged in a particular order? So this is also permutation. We have 6 teams. So we have 6 factorial, 6 times 5 times 4 times 3 times 2 times 1, or that is 720. There are 720 ways that we can arrange the 6 teams in particular order. Keyword: particular order. Mr. Nell wants to order a sandwich with 3 of the following ingredients: mushroom, eggplant, tomato, and avocado. How many different sandwiches can Mr. Nell choose? So this is an example of combination. Since if we are going to choose 3 out of the following ingredients, order does not matter. So if we choose mushroom, eggplant, tomato, it is also the same as choosing eggplant, mushroom, tomato, or choosing tomato, eggplant, mushroom. Okay, so we have combination. How many objects do we have? We have 4, namely mushroom, eggplant, tomato, and avocado. How many options we should make? We have 3. So this is combination of 4 taken 3 at a time. That is 4 factorial divided by 3 factorial times 4 minus 3 factorial. 4 minus 3 is equal to 1. Using calculator, the answer is 4. There are 4 different sandwiches Mr. Nell can choose from. If there is a total of 13 objects, how many combinations of 5 objects can be chosen? We have the keyword combinations. So we will use the combination rule. That is combination of 13 taken 5 at a time. Or 13 factorial all over 5 factorial is equal to 13 minus 5 factorial. 13 minus 5 is equal to 8. Using calculator, the answer is 1287. There are 287 combinations. A calculus test contains 5 different questions labeled A, B, C, D, and E. You are supposed to choose 2 to answer. How many different ways are there to do that? This is also an example of combination. If we're choosing 2, let's say AB, it is also the same as BA. So this is combination of 5 taken 2 at a time, which is equal to 5 factorial is equal to 2 factorial times the difference of 5 and 2 factorial. 5 minus 2 is equal to 3. Using calculator, the combination is 10. Now let's find, or let's say determine the following if it is an example of mutually exclusive or not mutually exclusive. So given the following events: event A, rolling a die and getting a 4. Rolling B, rolling a die and getting a number. Now, what's the difference between mutually exclusive and not mutually exclusive? In mutually exclusive, the intersection is equal to null set or empty set. In short, there is no intersection between the two events. If there are no intersection or common to the two events, then it is said to be mutually exclusive. Now let's determine. Event A, getting a 4. Event B, getting an odd. Is 4 an odd number? No. Therefore, it is mutually exclusive. There is no common to 4 and odd number. No common to 4 and odd number. That's why it is mutually exclusive. Given that a student is to be selected as class president, event A, Nell being selected as a president, event B, Len being presented as a president, is there any similarity between event A and event B? Yes, and the common is being a president. This is not mutually exclusive. A card is drawn from ordinary deck of playing cards. Event A, drawing a club. Event B, drawing a diamond. Is there any common to club and diamond? No, there is no common to club and diamond. Thus, this is mutually exclusive. A ball contains 3 green balls and 5 red balls. Event A, picking a green ball. Event B, picking a brown ball. Is there any connection or is there any common between green and brown? No. This is an example of mutually exclusive. Now let's look for the dependent event and independent event. Random selection of 2 playing cards from a standard 52 card deck. First selection is not a phase and should be replaced before selecting the next card. Now let's differentiate first the difference between dependent and independent. So independent, dependent event, the event A or the first event has an effect on the result of the event B. So in short, the first event does or have an effect on the result of the second event. If there is no effect between the 2 events, then it is said to be independent. Now, going back, first selection is not phased. When we talk about not phased, we're looking for A's 2, 3, 4, 5, 6, 7, 8, 9, 10. Either club, heart, diamond, or spade. Second, it should be replaced, so we will place again the first selection before selecting the next card. Is there any effect on that? Yes, the answer is there is. This is an example of dependent event because of the word replaced. Tossing a coin and picking a marble in a jar. Is there any resulting effect on tossing a coin when picking, or rather, is there any resulting effect on picking a marble in a jar when we toss a coin? No. The sample space of tossing a coin is head or tail, while the sample space of picking a marble jar is the different colors. So there's no connection. This is an example of independent effect. Rolling a die twice and getting a sum of 11. Rolling a die twice. What are the sample space? Either 1, 2, 1, 1. So we have 36 in total. So pair. Second event, getting a sum of 11. So what are the sample space? We have 5, 6 or 6, 5 only. And 5, 6 or 6, 5 can be found in the sample space when we roll a die twice. So there is an effect on the result. This is an example of dependent effect. Now, in an examination, a junior high school student may choose to solve 4 out of 12 word problems. In how many ways can the student choose the word problems? So this is an example of permutation. 4 out of 12 word problems. So we have permutation of 12 taken 4 at a time. Or 12 factorial is equal to 12 minus 4 factorial. 12 minus 4 is equal to 8. Using your calculator, the answer is 11,880. Find the probability of drawing a club, the heart from an ordinary deck of beauty to playing cards without replacement. Our keyword is without replacement. We're looking for the probability. Now we have two events here, either union of events or intersection of events. So what's the difference? So here, without replacement, we will use the intersection of events. Okay, keyword without replacement or unreplaced. So how should, or what is the formula of the intersection of the events? That is simply get the probability of the first event, then multiply to the probability of the second event after the first event. Now, there is an effect on the total sample space of the second event. Without replacement, take note. So we have probability of drawing a club. We have 13 clubs in a 52 cards. That's why 13 over 52. That is the probability of drawing a club. 13 over 451 is the probability of drawing a heart. Since we have 13 hearts out of 52 cards, since we have no replacement here, on the first event we get 1 card. So on the second probability of the second event, we will have 1 minus, okay, on the total sample space. So instead of over 52, we will now have over 51. So 13 over 52 times 13 over 51. Then multiply or simplify rather. 13 over 52 is also the same as 1/4 and multiply. 1 times 13 is 13. 4 times 51 is 204. We cannot simplify this further. This is the probability of the first event intersects a second event. A group of students wants to create a committee of 5 students by choosing 3 out of 6 grade 10 students and 2 out of grade 5 students, grade 9 students rather. In how many ways can the members of the committee be selected? So this is an example of combination. Okay, so take note that we have 3 out of 6. So we will have combination of 6 out of 3 multiplied by grade 9 students. 2 out of 5, that is combination of 5 taken 2 at a time. Combination of 6 taken 3 at a time. Multiply combination of 5 taken 2 at a time. Simplify using calculator, the answer is 200. There are 200 ways that members of the committee be selected. Last question. Suppose the bag has 5 blue marbles, 6 brown marbles, and 7 black marbles. Mr. Nell is to pick a marble and record its color, then put it back inside the bags and pick again. What is the probability of picking a black marble followed by a brown marble? So we have probability of black marble intersects to the probability of brown marble. We will have 7 over 18 multiplied by 6 over 18. Since caution there is a put it back inside. So there is replacement. So instead of 6 over 17, it must be 6 over 18. And 6 times 6 over 18 is also the same as 1/3. Corrections is on the comment box. So again, this is 7 over 18 times 6 over 18. Since we are going to put the first picking, which is the black marble, okay, inside the box. So 7 over 18 is equal times 6 over 18 is also the same as 7 over 18 times 1/3. Okay, 7 times 1 is equal to 7, and 18 times 3 is equal to 54. So 7 over 18 times 1/3 is equal to 7 over 51. We cannot simplify this further, and that is the final answer. 7 over 54 rather. 7 over 54. That is the probability of picking a black marble followed by a brown marble. That would be all for today. Good luck to your exam.